Welcome to Lesson 2.2. Today we're going to talk about linear relations and functions. Go ahead and pause the video and write down the vocab before continuing on. Our first vocab term is linear relations, and that is relations that have straight line graphs. We also have nonlinear relations, which are relations that don't have that straight line graph, so they're not linear. Linear equation is an equation that has no operations other than adding, subtracting, and multiplication of a variable and a constant. We have a linear function, which is a function with ordered pairs that satisfy a linear equation. Standard form is a linear equation in the form of ax plus by equals c, where a, b, and c are integers with a greatest common factor of 1. Y-intercept is the y-coordinate at which the graph crosses the y-axis, and an x-intercept is the x-coordinate where the graph crosses the x-axis. So that should say x, not y. So the first thing we're going to do is we're going to identify linear equations. So in order to be considered a linear function, an equation must not have these three things. It can't have a variable exponent other than 1. It can't have two variables being multiplied together, and it can't have a variable in the denominator of a fraction. So if an equation doesn't have any of these three things, then we would call it linear. If it does have one or more of them, it is not linear. Okay, so what they're going to do is they're going to give you an equation, and they're going to say state whether each function is a linear function. So we take a look here. First one, f of x is equal to 8 minus 3/4 times x. We look for, does the variable have an exponent other than 1? No, it does not. Do we have two variables being multiplied together? No. Do we have a variable in the denominator? No, because that 3/4 is being multiplied by x. The x is not on the bottom with the 4, so we would say that this is in fact a linear function. Second one, 2 over x. So we go through our rules. First of all, do we have an exponent other than 1 for our variable? No. 2, do we have two variables being multiplied together? No. 3, do we have a variable in the denominator? Yes, we do. So this is not a linear function because we can't have a variable on the bottom. For our last one, we've got g of xy is equal to 3xy minus 4. First thing, do we have a variable exponent other than 1? No. Do we have two variables being multiplied together? Yes, we do. So this is also not a function. Go ahead and pause the video and determine whether these two are functions or not before hitting play and seeing how you did. First one, we got 5 over x plus 6. This is not a function or a linear function because we have a variable in the denominator. Second one, negative 3/2 x plus a third. That is a function because again the x is not on the bottom of the fraction. It is just being multiplied by negative 3/2. So now we're going to evaluate linear functions. So we've got this example problem. We've got the growth rate of a sample of Bermuda grass is given by the function b of x is equal to 5.9x plus 3.25, where b of x is the total height in inches, x days after the initial measurement. So the question is, how tall is the sample after 3 days? So that means we're going to take x and we're going to plug 3 in for it. So b of 3 is equal to 5.9 times 3 plus 3.25. And if we plug that in, we should get that it is 20.95 inches tall. So now the term 3.25 in the function represents the height that it originally measured at. Okay, so they want to know how many times is tall in 3 days. So we would take our 20.95 that we just found, and we would divide it by our original amount of 3.25, and we would get roughly 6.45 times as tall. Go ahead and pause the video and do this example problem before hitting play and seeing how you did. Okay, so now the problem is saying the grass is 50.45 inches tall now. and they want to know how many days it's been since it was cut. So we put the 50.45 in for b of x, because b of x is our current height. And then we solve for x by subtracting 3.25 from both sides. We get 47.2 is equal to 5.9x. Divide both sides by 5.9, and we get that it was cut 8 days ago. So now we're going to talk standard form. So again, the standard form of a linear equation is ax plus by equals c, where a, b, and c are integers with the greatest common factor of 1. So all three of them have a greatest common factor of 1, a, b, and c. Now a has to be greater than or equal to 0, and a and b both can't be 0. Okay, so those are the rules for standard form, but they have to be integers is the biggest thing here. Okay, so now our first problem is write negative 3/10 times x is equal to 8y minus 15 in standard form. So then we're going to identify a, b, and c. So the first thing we need to do is we need to have x and y on the same side. So I'm going to subtract the 8y over to the other side, and I'm going to get negative 3/10 x minus 8y is equal to a negative 15. Now, the last thing is, what's in front of x is not an integer. Negative 3/10 is not an integer, so I need to multiply everything by some number that will get rid of this fraction. Well, whatever's on the bottom, that's what I multiply by, so I'm going to multiply everything by 10. What that's going to do is it's going to give me a negative 3x minus 80y equals a negative 150. The last thing is that a has to be greater than or equal to 0. Right now it's negative. So I take this and I multiply it by a negative 1, and I get 3x plus 8y equals a positive 150. And so when I identify a, b, and c, a is in front of x, b is in front of y, c is all by itself. So a is 3, b is 8, and c is 150. Our second example, we've got 2y equals 4x minus 5 in standard form, and then identify a, b, and c. So first thing, I need to get x and y on the same side, so I'll subtract 4x from both sides. X is always written first, so negative 4x plus 2y equals 5. Okay, so now they're all integers, but a isn't positive. So again, I need to multiply everything by that negative 1, giving me 4x minus 2y equals a negative 5. So now I identify a is 4, b is a negative 2, and c is a negative 5. Go ahead and pause the video and write this in standard form and identify a, b, and c, and then hit play, see how you did. So all you should have had to do was add 9 to both sides, so giving you 3x minus 6y equals 9. Then you identify a as positive 3, b as a negative 6, and c was 9. Now we're going to use standard form to find intercepts to graph a line. So when we have the equation 2x minus 3y plus 8 equals 0, and I want to find the x and y intercepts and then graph it, first thing I need to do is get it into standard form. So I subtract 8 from both sides, giving me 2x minus 3y equals a negative 8. So now, when I want to find the x-intercept, I take the x part and I set it equal to c, and I solve for x. Divide both sides by 2, and I get that x is a negative 4. So on the x-axis, I put a point at negative 4. For the y-intercept, I take the y part, the negative 3y, and I set it equal to negative 8, and then I solve for y, dividing both sides by negative 3, giving me y is equal to 8/3. So on the y-axis, I find 8/3, which is roughly here, and I put the point there. And now I've got my 2 points. I can connect with a line and extend. So when we get it into standard form, to find the x-intercept, you take the term with x in it, set it equal to the right, and solve. To find the y-coordinate, you take the y term and set it equal to the right and solve. Put the points down and connect them with a line. Go ahead and pause the video and find the 2 intercepts and graph this equation, then hit play, see how you did. Okay, so you should have first added 10 to both sides. You get 2x minus 5y equals 10. Then to find the x-intercept, you take 2x equals 10, divide both sides by 2, and get x equals 5. To find the y-coordinate, you do negative 5y equals 10, divide both sides by negative 5, and you should get y is equal to a negative 2. Plot both of those points, connect them with the line, and you're finished.